All right, welcome to the deep dive. Today, we're setting our sights on, well, space.
To infinity and beyond.
Well, maybe not quite infinity, but definitely a deep dive into NASA, the National Aeronautics and Space Administration.
Yeah, one of those organizations that just, captures the imagination.
Absolutely. And you sent us a great Wikipedia entry, super in-depth. So our mission, should we choose to accept it, is to break down that massive amount of information.
Extract those golden nuggets, those aha moments.
Right. Because let's be honest, Wikipedia can be a bit of a rabbit hole sometimes, right?
No, yeah. You start reading about, say, the space shuttle, next thing you know, you're knee-deep in rocket engine designs.
Exactly. So we're going to give you the highlights reel, the most fascinating and crucial bits about NASA, where it came from, what it's accomplished, and where it's headed.
And your source is fantastic for that. It covers everything, from NASA's creation to its current projects, from those iconic moon landings to the robotic explorers out there right now.
Yeah, it even touches on some of the controversies and challenges, budget debates, the role of private companies, that kind of thing.
All part of the story, right? The big picture of NASA.
Exactly. So think of this as your express ticket to understanding NASA. No need to spend hours sifting through the details yourself.
We've done the heavy lifting for you.
And we're going to try to make it fun along the way. Keep it conversational. So to kick things off, let's go back to the very beginning. Because NASA, believe it or not, wasn't the first organization in the U.S. focused on flight. There was actually a predecessor.
You're talking about NASA, right? The National Advisory Committee for Aeronautics?
That's the one. Established in 1915. Now, this is interesting. The U.S., despite being, the birthplace of aviation with the Wright brothers and all.
Yeah, they were kind of falling behind. Europe was making serious strides in aircraft technology.
Exactly. So NASA was formed to close that gap, restore American dominance in the air. Sounds familiar, right?
It's a recurring theme for sure.
And for decades, Messier focused solely on aeronautics. But then came World War II, right?
Things shifted, the focus expanded.
They created the Pilotless Aircraft Research Division. Kind of mouthful. But despite the name, this was all about
rockets.
Rockets. And that early research laid the groundwork for what was to come. Because then, in 1957, something happened that sent shockwaves across the globe.
Sputnik. Gotta be Sputnik.
Sputnik. The Soviet Union launches this little satellite, and it basically changes everything.
Oh yeah, it was a huge wake-up call for the U.S. Kicked off the space race in earnest. Suddenly, space wasn't just some sci-fi fantasy anymore.
And the pressure was on.
Right.
To catch up. Now, Nessie had been doing some rocket work, but the first U.S. satellite project actually went to the Naval Research Laboratory.
Project Vanguard. But they had some hiccups. So it was actually the Army Ballistic Missile Agency that launched the first successful U.S. satellite, Explorer 1, in 1958.
So you've got this scramble to get into space, multiple agencies involved, and President Eisenhower realizes, okay, we need to get organized here.
A unified approach, and separate civilian from military efforts in space.
Right. So on July 29th, 1958, he signs the National Aeronautics and Space Act. And just like that, NASA is born.
Starts operations on October 1st, 1958. Pretty quick turnaround, actually.
And they didn't start from scratch, did they? NASA basically absorbed NASA, bringing all those experienced people and research facilities under one roof.
About 8,000 employees in those 3 major research labs.
Plus, they took over Project Vanguard, snagged the Jet Propulsion Laboratory from the Army, and perhaps most significantly,
Werner von Braun's team. The rocket geniuses from the Army Ballistic Missile Agency.
The German Rocketeers, who just a decade earlier had been on the other side of a major war.
History is full of these interesting twists and turns.
It is. So NASA is up and running, fueled by the space race, the Cold War rivalry with the Soviets. And the next obvious step is
humans in space. Gotta get a man up there.
And what's fascinating is the groundwork for that was already being laid, even before NASA existed, within the U.S. military.
The Air Force had their Man in Space Soonest project, very to the point name, right?
No beating around the bush there. And the Army had Project Atom. So these early military ideas formed the basis for NASA's Project Mercury.
Led by the Space Task Group, a dedicated team to tackle this monumental challenge.
And the plan, at least initially, was to use different rockets depending on the mission.
Yeah.
Redstone rockets from the Army for suborbital flights.
Yeah.
The ones that don't quite make a full orbit.
Like a really, really high arc, up and then back down.
And for the orbital missions, the ones that actually circle the Earth, they were going to use the Air Force's Atlas rockets. Much more powerful. Now, when it came to choosing astronauts, you might think, okay, test pilots,
Yeah.
experienced military guys.
The right stuff. But NASA actually initially leaned towards civilian astronauts.
Really?
Yeah. But President Eisenhower stepped in and said, nope, gotta be military pilots for the first astronauts.
So enter the Mercury 7, these legendary pilots from the Air Force, Navy, and Marine Corps.
Alan Shepard, Gus Grissom, John Glenn, to name a few. Household names now.
And it was Alan Shepard who became the first American in space. May 5th, 1961, piloting the Freedom 7 capsule on a suborbital flight.
Less than a month after Yuri Gagarin, the Soviet cosmonaut, made the first orbital flight. So, a bit of a mixed bag, right? Huge achievement, but still chasing the Soviets.
Definitely a competitive atmosphere. And it wasn't long before NASA achieved its own orbital flight. February 20th, 1962, John Glenn in Friendship 7, 3 orbits around the Earth. And there was a bit of drama during that flight, wasn't there?
Oh yeah, the autopilot malfunctioned. Glenn had to manually control the spacecraft for parts of the last 2 orbits. Talk about nerves of steel.
Shows you the kind of skill these early astronauts had. And the Mercury program wrapped up in May 1963 with Gordon Cooper's 22-orbit flight. So the duration and complexity are really ramping up. Now, amidst all the excitement of putting humans in space, it's important to remember that NASA never abandoned its aeronautics roots. This wasn't just about reaching out to space, it was also about pushing the boundaries of flight here on Earth.
Absolutely. And one of the coolest examples of that is the X-15 program, a joint project with the Air Force.
The X-15. Now, that was a special aircraft, a hypersonic rocket plane. And get this, it actually became the first non-dedicated spacecraft to cross into space.
Yeah, I mean, it was designed for atmospheric flight, but it reached space. Crazy.
And it wasn't just about breaking speed and altitude records. The X-15 was a test bed for a lot of technologies that were later crucial for the Apollo program. Heat-resistant materials, re-entry control systems, that sort of thing.
That also paved the way for future hypersonic research, still relevant today.
All right, so the scene is set. NASA is established. Americans have been to space. Aeronautics research is ongoing. And then comes President Kennedy with a challenge that seems almost impossible at the time.
Land a man on the moon before the end of the decade. And bring him back safely, of course.
1961, Kennedy gives that famous urgent national needs speech to Congress. He lays out this vision, this incredibly ambitious goal, and it wasn't just about science.
Oh no, this was about Cold War competition, showing the world that the U.S. was the technological leader.
A year later, Kennedy gives another iconic speech, the one at Rice University. We choose to go to the moon. Goosebumps every time.
He was a master at inspiring the nation.
And he put his money where his mouth was, so to speak. Kennedy fiercely protected NASA's budget, which was growing rapidly. At one point, 50% of that budget was dedicated to human spaceflight.
And at its peak, the Apollo program employed something like 5% of the entire American workforce. That's how massive this undertaking was.
5%. Mind-boggling.
Yeah.
And to manage a project that huge, NASA looked to the Department of Defense. They had experience with large-scale projects.
Like, developing those intercontinental ballistic missiles. Not exactly peaceful, but the know-how was there.
So they brought in Major General Samuel C. Phillips from the Air Force to direct the Apollo program and to lead the development of the rocket that would get them to the moon, the Saturn V.
Wernher von Braun, back again.
The man was a rocketry legend. Him and his team at the Marshall Space Flight Center in Huntsville, Alabama.
Building on their work with the Saturn I rocket?
Meanwhile, North American Aviation was building the Apollo spacecraft, the command and service modules, and Grumman was tackling the lunar module, the one that would actually land on the moon. But jumping straight to a lunar landing, that was just too big a leap. They needed to develop the skills and technology first, hence Project Gemini.
Gemini was all about bridging the gap between the relatively simple Mercury missions and the much more complex Apollo.
So Gemini focused on things like extended space flights, spacewalks, rendezvous, and docking in orbit.
Basically, all the maneuvers they'd need to pull off a successful lunar landing. And it was a huge success, paved the way perfectly.
And before sending humans, they sent a bunch of robotic explorers to the moon. Scouts, essentially.
The Ranger program sent back some early images, but it had its fair share of failures. The Lunar Orbiter program was much more successful, mapped almost the whole lunar surface in high resolution, helped them pick landing sites for Apollo.
And then there was the Surveyor program. Soft landings on the moon.
Testing out the whole landing process, analyzing the lunar soil. Super important for designing the lunar module.
But then, tragedy struck. January 1967, the Apollo 1 fire. A devastating setback. 3 astronauts lost. Gus Grissom, Ed White, and Roger Chaffee.
A stark reminder of the inherent risks of space exploration.
But the program continued with a renewed focus on safety. And just a year later, December 1968, comes Apollo 8, a truly landmark mission.
Apollo 8 was the first crewed spacecraft to leave Earth's orbit and the first to reach the moon. They didn't land, but they orbited the moon 10 times. Frank Borman, James Lovell, and William Anders.
And they gave us that iconic Earthrise photo, that image of our blue planet hanging in the black void of space, changed our perspective forever.
Really put things into perspective, didn't it? The fragility of our planet, our place in the vastness of space.
And then, just 7 months later, Apollo 11, July 20th, 1969. Neil Armstrong, Buzz Aldrin, and Michael Collins.
One small step for man, one giant leap for mankind.
The first humans to walk on the moon. A moment that captured the imagination of the entire world. And the culmination of the space race, really.
The Soviets conceded defeat. They'd been aiming for the moon too, but after Apollo 11, it was clear who was leading the pack.
Apollo continued for a few more years. 6 successful lunar landings in total. Each mission building on the last, doing more science, exploring further with the lunar rover.
Apollo 17, the last one, was in 1972, and then that chapter closed.
But Werner von Braun, the rocketry mastermind, he had a bigger vision. He'd been advocating for a space station, a permanent human presence in space.
And that vision came to fruition, at least partially, with Skylab.
Skylab, launched in 1973 using the last Saturn V rocket, basically a repurposed Apollo and Saturn hardware. But the launch didn't go perfectly, did it?
Oh no, there was some damage. A solar panel and a micrometeoroid shield got messed up. The first crew had to do some emergency spacewalks to fix it.
Talk about pressure. But they got it working, and Skylab hosted 3 missions, 9 astronauts in total.
They did a ton of science up there, observing the sun, studying the Earth, even doing medical experiments.
Skylab was decommissioned in 74, and it eventually deorbited in 79.
Sad to see it go, but it paved the way for future space stations, like, the one we have now.
And in 1975, we had another significant moment in space history. Apollo-Soyuz, a joint mission between the U.S. and the Soviet Union.
Right in the middle of the Cold War, a real symbol of détente. An American Apollo spacecraft and a Soviet Soyuz capsule docked in orbit. Astronauts and cosmonauts working together.
A glimmer of hope in a very tense time. And it also marked the last flight of the Apollo Command and Service Module. So Apollo comes to an end, Skylab is gone, and NASA turns its attention back to robotic exploration of the solar system. And this is where they really start branching out, exploring all sorts of planets and moons.
And it all starts with the Mariner program in the 60s, sending probes to Venus, Mars, and Mercury.
Mariner 2 was the first to successfully fly by Venus in 1962, and it dashed some hopes, didn't it?
Oh yeah, people had this idea that Venus might be, a kind of Earth-like paradise. But Mariner 2 showed that it's actually a super hot, hellish place.
Definitely not vacation material.
Yeah.
And later, we had missions like Pioneer Venus and Magellan, which used radar to map the surface of Venus, because you can't see through those thick clouds with regular cameras. And then there's Mars, of course. The red planet. Always captured the imagination. The question of life on Mars has been around forever.
And NASA has been obsessed with Mars for decades. Mariner 4 did the first flyby in 65, sent back the first close-up pictures. Mariner 9 was the first to orbit Mars. And then came Viking in 76, the first successful landings.
2 landers, Viking 1 and Viking 2. And they actually did experiments looking for signs of life.
Didn't find anything conclusive, but it was a huge step forward.
And after a bit of a break, Mars exploration really picked up again in the late 90s and early 2000s.
Yeah, we had orbiters like Mars Global Surveyor and Mars Odyssey mapping the planet in incredible detail.
And then the rovers, Sojourner, Spirit, Opportunity, and Curiosity.
Right.
Each one more advanced than the last. Curiosity especially has been a huge success.
Still going strong today, over a decade later, found evidence of past liquid water, organic molecules, the building blocks of life, and it even measured radiation levels, crucial information for planning human missions to Mars.
More recently, we've had MAVEN N studying the Martian atmosphere, InSight probing the planet's interior, and of course Perseverance, with its little buddy Ingenuity, the first helicopter to fly on another planet.
Perseverance is searching for signs of ancient microbial life, and it's collecting samples that might one day be brought back to Earth.
Amazing stuff. And it's not just the inner solar system that NASA's been exploring. They've sent probes to all the gas giants and beyond.
Yeah, the Pioneer missions were the pioneers, so to speak. Pioneer 10 crossed the asteroid belt and reached Jupiter in 1973. Pioneer 11 did a flyby of both Jupiter and Saturn. And both of those spacecraft are now on trajectories that will take them out of the solar system entirely, the first human-made objects to do so.
Then came Voyager, launched in 1977. Two spacecraft, Voyager 1 and Voyager 2, took advantage of a rare planetary alignment to do flybys of all four gas giants, Jupiter, Saturn, Uranus, and Neptune.
Voyager gave us those stunning images of those planets and their moons, those pale blue dots, those swirling clouds, those rings. Incredible.
And they're still sending back data today from interstellar space.
Yeah.
Mind-blowing.
Voyager will likely outlive humanity, just cruising through the galaxy, carrying our message in a bottle.
Galileo orbited Jupiter, studied the planet and its moons in detail, found evidence of a subsurface ocean on Europa.
Europa is one of the most promising places in the solar system to look for life. That ocean could be teeming with, well, who knows what.
Huygens went to Saturn, studied the rings, the moons, the whole system. Huygens even landed on Titan, a moon with lakes and rivers of liquid methane. Crazy.
And Cassini found evidence of subsurface oceans on Enceladus, another one of Saturn's moons. So many potential habitats for life out there.
And then there's New Horizons. Launched in 2006, it reached Pluto in 2015, giving us our first close-up look at that dwarf planet. And now it's exploring the Kuiper Belt, the region beyond Pluto. So we've been to all the planets. But NASA's exploration doesn't stop there. They've also launched a whole fleet of space telescopes, giving us views of the universe we could never get from Earth.
Space telescopes, yeah, they're like our eyes on the cosmos, and they've revolutionized astronomy.
It all started with the orbiting astronomical observatories in the 60s. But the real game changers were the great observatories, launched in the 90s and early 2000s.
Hubble, Compton, Chandra, Spitzer, each one observing the universe in a different part of the electromagnetic spectrum.
Hubble, of course, is the most famous, launched in 1990. Those incredible images, galaxies billions of light years away, nebulae, star clusters, all sorts of cosmic wonders.
And it was serviced and upgraded multiple times by the Space Shuttle, which extended its lifespan significantly.
Compton, the Gamma Ray Observatory, studied the most energetic phenomena in the universe. Exploding stars, black holes, that kind of thing.
Chandra, the X-ray observatory, looked at things like superheated gas around black holes and galaxy clusters.
Their Spitzer, the infrared telescope, could see through dust clouds, which is great for studying star formation.
And together, these great observatories gave us a much more complete picture of the universe.
And they've also contributed to our understanding of the very origins of the universe. The Big Bang Theory, that the universe started from a single point and has been expanding ever since.
Missions like COBE and WMAP provided some of the key evidence supporting that theory. And now we have the James Webb Space Telescope, launched in 2021. Hubble's successor, basically.
Webb is an infrared telescope too, but much larger and more powerful than Spitzer. It can see even further back in time, closer to the very first galaxies that formed after the Big Bang.
It's already making incredible discoveries. And it's just getting started.
And speaking of incredible discoveries, NASA has been at the forefront of the search for exoplanets, planets orbiting other stars.
Kepler, launched in 2009, was a dedicated exoplanet hunter. Stared at a patch of sky for years, looking for tiny dips in starlight caused by planets passing in front of their stars.
And it found thousands of potential exoplanets,
including some Earth-sized ones in the habitable zones of their stars, the zones where liquid water could exist. So, potentially habitable.
Now, it's important not to forget NASA's work here on Earth science, because they're not just about exploring out there, they're also about understanding our own planet.
Absolutely. NASA has a whole fleet of Earth-observing satellites, studying our climate, our oceans, our ice caps, everything.
TIROS, launched in 1960, was the very first weather satellite, and since then they've been working closely with NOAA, the National Oceanic and Atmospheric Administration.
Landsat, launched in 1972, was the first dedicated Earth observation satellite, focused on monitoring land resources. And the GOES program, those are the geostationary weather satellites.
The ones that give us those constant weather updates, super important for forecasting and understanding weather patterns.
And let's not forget the discovery of the ozone hole that came from data collected by NASA satellites.
So NASA is watching over our planet, giving us vital information about how it's changing. Okay, so we've talked about the early days, the moon landings, robotic exploration, space telescopes, Earth science. Now let's move on to another iconic chapter, the Space Shuttle program.
The reusable space plane, a technological marvel.
A bold idea. Develop a spacecraft that could launch like a rocket, orbit the Earth, and then land like a glider.
And reuse it, cutting down the cost of space travel. That was the big idea, at least.
And the development of the shuttle was a huge undertaking, involving multiple NASA centers. Johnson Space Center in Houston led the development of the orbiter, the part that carries the crew and payload.
Marshall Space Flight Center in Alabama tackled the launch system, those solid rocket boosters, the external tank, all that.
There was actually an early test vehicle, Enterprise. Never flew in space, but it did atmospheric flight tests, gliding back to Earth.
Paving the way for the operational orbiters, Columbia, Challenger, Discovery, Atlantis, and Endeavour, each one a technological masterpiece.
And the space shuttle enabled NASA to bring a much more diverse group of people into space. No longer just test pilots.
We had scientists, engineers, even teachers flying on the shuttle. Sally Ride, the first American woman in space, flew on the shuttle in 1983.
And astronauts from other countries too. International collaboration became a big part of the program. The first shuttle flight, STS-1, was in 1981, Columbia lifting off from Kennedy Space Center. A truly spectacular sight.
A huge moment for NASA.
And the shuttle was more than just a people mover. It launched satellites, carried scientific experiments in its cargo bay.
Space Lab was a key part of that. A modular laboratory developed by the European Space Agency. Astronauts could do all sorts of science up there.
The shuttle even demonstrated on-orbit satellite repair. In 1984, they fixed the Solar Maximum Mission satellite, which had malfunctioned. That was a big deal.
Showed the versatility of the shuttle.
But the program wasn't without its critics. The cost overruns, the complexities of reusability.
And then, of course, the Challenger disaster in 1986, a national tragedy.
STS-51L Challenger broke apart shortly after launch, killing all 7 astronauts on board. A horrible day for NASA.
Grounded the fleet for 2.5 years, led to a major reassessment of safety procedures.
When the shuttle program resumed, it was with a much greater emphasis on safety. And in the 90s, we saw the Shuttle Mir program.
Collaboration with Russia, American shuttles docking with the Mir space station, Russian cosmonauts flying on the shuttle.
Post-Cold War cooperation in space. A really positive development.
But Mir had its own problems, some technical issues, even a fire on board.
And then came another tragedy. The Columbia disaster in 2003, STS-107. Columbia disintegrated during re-entry, killing all 7 astronauts.
A devastating loss. Another investigation, another round of soul-searching, and ultimately the decision to retire the shuttle program.
The final shuttle flight was in 2011, the end of an era. Which brings us to the International Space Station, the ISS, the largest and most complex space structure ever built, a true symbol of international collaboration. But the idea for a large space station goes back a long way.
Even before the shuttle, NASA had been dreaming of a permanent human presence in space for decades.
In 1984, President Reagan directed NASA to develop a space station, which was initially called Space Station Freedom, and it was planned to be an international project from the start.
But Space Station Freedom ran into problems, cost overruns, design changes. It was really struggling to get off the ground.
And then came a pretty radical idea: merge Space Station Freedom with Russia's planned Mir 2 station.
This is in the early 90s, after the collapse of the Soviet Union. Russia's space program was in trouble, needed a boost.
And so the International Space Station was born, a collaboration between the US, Russia, Europe, Japan, and Canada.
A truly global effort. And the construction was incredible. Launching all those modules, assembling them in orbit, took over a decade.
The US provided most of the modules and launch vehicles, but the other partners made significant contributions. And the ownership and operation of the ISS is all governed by these complex international treaties.
Yeah, it's divided into the US segment and the Russian segment. Each partner has their own section.
And the ISS has been continuously occupied since November 2000, over 24 years now.
Longer than any other space station. And astronauts from 15 different countries have lived and worked there.
It's so large you can actually see it with the naked eye, if you know where to look, of course.
And getting people and supplies up there is a continuous process. Currently, it's the Russian Soyuz, the SpaceX Crew Dragon, and the Boeing Starliner for Kourou.
And cargo is delivered by the Russian Progress, the European ATV, the Japanese HTV, and the SpaceX Dragon and Northrop Grumman Cygnus. Busy place.
It was the shuttle that did most of the heavy lifting during the assembly phase, though. And for a while after the shuttle retired, the only way for American astronauts to get to the ISS was on Soyuz.
A bit awkward, politically. But that changed with the success of SpaceX's Crew Dragon. Now, another really interesting development in recent years has been NASA's commercial resupply services and commercial crew programs.
Basically partnering with private companies to handle a lot of the transportation to and from the ISS.
It started with cargo delivery. then expanded to crew. SpaceX and Northrop Grumman have been delivering cargo for years now.
And SpaceX's Crew Dragon has been flying astronauts to the ISS since 2020. Boeing's Starliner joined the party in 2024.
So a big shift in NASA's approach, relying more on commercial providers, which allows them to focus on, well, bigger things, like the Artemis program.
Back to the moon. And this time they're talking about a sustainable presence, a base on the moon, a stepping stone to Mars.
Ambitious. But Artemis wasn't the first attempt at a lunar return. Remember the Constellation program?
Oh yeah, President Bush's vision. That was back in the early 2000s. But it was plagued by cost overruns and delays.
And eventually canceled by the Obama administration in 2010.
Which led to a lot of debate about, the future of human spaceflight. Some people argued that NASA should focus on research and development, leave the transportation to private companies.
Which, in a way, is what's happening now with the Commercial Crew program. And it seems to be working pretty well.
So Artemis is picking up where Constellation left off, but with a more collaborative approach. International partners are involved, and they're leveraging some of the hardware developed for Constellation.
Like the Orion spacecraft and the Space Launch System, or SLS. That's the big new rocket that will carry Orion to the moon.
Artemis Valve was an uncrewed test flight in 2022. Orion orbited the moon, came back successfully. Big milestone.
Artemis II, the first crewed mission, is planned for 2025. Just a flyby, but it'll test out Orion's life support systems and all that.
And then Artemis III, the big one. The first crewed lunar landing since Apollo 17. No earlier than 2026.
And they've already got plans for more Artemis missions after that. Building habitats, doing science, exploring the lunar South Pole, where there might be water ice.
And to get astronauts down to the surface, they're going with SpaceX's Starship, the big reusable spacecraft that's still under development.
So a public-private partnership for the actual landing part. Interesting times.
And another key element of Artemis is the Lunar Gateway, a small space station in lunar orbit.
Not permanently crewed, but it'll be a staging post for missions to the surface, a place to do research, and potentially a hub for future deep space missions.
Assembly is planned to start in 2027.
And back here in low Earth orbit, NASA is also supporting the development of commercial space stations. The idea is to eventually replace the ISS with these private stations.
They've already selected some companies like Blue Origin, Nanoracks, and Northrop Grumman.
So the future of low Earth orbit might be commercial, which would allow NASA to focus on those deep space ambitions. Now, let's not forget about all the incredible work NASA does with robotic missions. Over 1,000 unmanned missions so far.
Exploring all corners of the solar system and beyond.
And they have this whole framework for planning and executing these missions. Different programs for different types of missions.
Yeah, the Explorer program is for smaller, more focused missions in heliophysics and astrophysics. Discovery is for planetary science missions, a bit bigger.
And New Frontiers is for the really ambitious planetary missions, like New Horizons to Pluto and OSIRIS-REx to the asteroid Bennu.
And then there are the large strategic missions, the flagship missions. The James Webb Space Telescope is a recent example. Those are the really big, expensive ones.
And NASA has got robotic missions active all over the solar system right now. The Lunar Reconnaissance Orbiter is still mapping the moon.
Perseverance and Curiosity are roving around Mars, making discoveries. Juno is orbiting Jupiter, studying the giant planet's interior. OSIRIS-REx is on its way back to Earth with a sample from an asteroid.
New Horizons is out in the Kuiper Belt, exploring beyond Pluto. And Voyager 1 and 2 are still going strong out in interstellar space.
And that's just the planetary missions. In astrophysics, NASA has a whole suite of space telescopes. Hubble, Chandra, Swift, Fermi, and now James Webb, observing the universe in every wavelength imaginable.
And back here on Earth, NASA's Earth Science program is doing vital work, studying our climate, our oceans, our land.
They have satellites measuring carbon dioxide levels, tracking ice melt, monitoring deforestation, all sorts of things.
And they manage a vast amount of data, making it available to researchers worldwide.
It's not just about space, it's about understanding our own home planet too, because, we only get one.
And to communicate.